Hello everyone. Today we have another assignment to do which is related to the 8051 program or 8051 microcontroller. The assignment says it's about a crane packaging filling process. A crane package to be produced in a moving band, moving or move until there is below of filling tape. The filling tape fill the packages. The filling tape fill the packages is with the position sensor with the with filling tab motor for 0.5 seconds, and then the working belt continues. So the packages is then moving on the moving band until it reaches the sensor, which then it stops for 0.5 seconds and for the filling tab. And it get filled, the moving belt continues and then the fill back is exactly on the rotation part. The package on the rotation motor is rotated. So there's a sensor with the rotation part, and the package is rotated until the color sensor detects the color square on the package. When the sensor detects the square, the motor stop and the lower side of the package is pressed with the upper press. So the packaging is carried out so that the cream level is ahead. Write down the 8051 assembly program code for the system. All sensor connection pins and output are given in the tab below. Implement your code that will provide desired result with the purchase simulation file. You can stimulate purchase by using on-off switches for sensor and lead for motors. Okay, we have inputs and outputs for this program. For inputs, we have the filling tab position sensor to pin 1.0, rotation sensor for pin 1.1, color sensor for pin 1.2. And then we have the outputs belt motor to pin 2.0, rotation motor for pin 2.1, press motor for pin 2.2, and filling tab motor for pin 2.3. Okay, now we have like a 4 to 3 process. Okay, as I did the code, I'll try to break it down for you. So we have a routine first, which is original 000H, and then with the end, it's the routine for the program. First, we have the original 00H, which indicate the start of the program, and then we have sjump, start. So the program will jump. It is a abbreviation to short jump. So the system will jump to start, which is start indicate that set B 2.0, which we have it as the pelt motor, so that the packaging start and the package get moved in the pelt motor. Okay, we then have check fill. This is for the tab sensor, the filling tab sensor, to check if the filling tab sensor is getting triggered. And then if it get triggered, then the program go to the fill packet. Okay. First we have GB B1.0 fill packet. Okay. If the system or if the filling tab motor is triggered, then the system will not go to this part, it will go to the fill packet. If it's not triggered, then the system will go here and it get back to here, check fill, or checking if the filling tab is triggered so that it can fill the packages. Okay, and then we have the fill packet, which indicate that the package is getting filled or need to get filled. So we have clear P2.0, which is If the build motor is set 1, set B, this means 1 start. We clear the 1 so that the build motor stops. And then we have P2.3, which is the filling tab motor. Okay, we set B, set pit P2.3, start the filling tab motor. And then we have a delay, as is said in the assignment, delay for 0.5 seconds. A called delay, which the delay we don't define it here with the delay, we define it outside of it because it calls the delay. Then we have the delay, move R2 to 100 decimal, move R1 to 150 decimal, and move R0 to 150 decimal. We define the R0, R1, and R2, and then we use the DT and Z, the discrement jump if not 0. So here the delay will always happen here in this part. And if it's 0, go to the next. If it's 0, go to the next. And if it's 0, go to the next. If it's not 0, always go to what we defined here. So if R0 is not 0, it will go here to D3. DJ and Z R1, D2. After this reaches 0, go to this line. And if R1 is not 0, it will always go to D2. DG and Z R2, D1. After this reaches 0. After this does not reach 0, it always goes to D1 until it's 0, and then we have the return command so that it returns to the delay or to this line. Then we stop for 0.5 seconds because the process needs to be 0.5 seconds for 2.5 seconds. Then we have clear P 2.3, which stop the filling process because the pin 2.3 is for the filling motor. Then we have P 2.0 build motor set to 1 because we need it to start moving the packages after it get filled. And then we have check rotations because we need to sense the color square. Okay, and check rotation or check rotate, we have the GB P1.1 rotate start because just check if the rotation started or the sensor triggered or not. And then we have S jump, check rotation or check rotate to keep checking if it get triggered. And then after that we have, if it get triggered, we have rotate start. We have the start of the rotation, which is clear B2 clear B 2.0, which start the build motor, and then we set pit for pin 2.1, which is the rotation motor to start the rotation. And then we have wait color to check the color square. GB B1.2, which is the color sensor for the square, check the square. And then if it get triggered, we will go to press label. If it not, we have the SJump boy color to keep checking if the color sensor find the color square and get triggered. Then we have press label. We clear P2.1 to stop the rotation, and because we already stopped the build motor, we don't have to stop it. We don't have to say clear B2.0 and then clear B2.1 because we already stopped the build motor for the rotation package. And then we set B2.2 to start the press motor, as we have here the press motor, and then we set bit B2.2, and then a call delay, again delay for 0.5 seconds, clear B2.2, which is the press motor, and S jump start the process again. So the press label is what it do is it after we fill the package, okay, then we check for rotation, and if the rotation is triggered, we then need to check for the color sensor to check the sensor square because the package need to rotate in a specific way, and then after that we have the press label to close the package after the filling, and we have at the end is end of the program, which is a routine. Thank you.